Good morning and welcome. I'm Kamala Desika and I'm the GTM lead for Cloud Platform and ISV ecosystem at Pivotal, focusing on Pivotal Cloud Foundry and partners like CloudBees. So Pivotal Cloud Foundry, in case you don't know, has been at the center of a lot of large-scale enterprise digital transformations where we have helped our customers with a modern platform and tooling, and often also take that a step further, where we work with them on the process and culture of their software practice. Now, our topic today is from DevOps to cloud native, ship software like a boss. Now, as a company, we have actually done this several times. Just to give you some examples, we've helped a major telco go from about 7 months just to do updates to same-day deployments. We've worked with a 100-year-old insurance company. We've helped major media company support over 1,500 developers with just an operator team of 4 people. And a major retailer that almost always had issues on Black Friday. It turned out that for the first time last year, they shipped to production essentially 1,500 times a month, and they had the first Black Friday that was completely smooth. Now, what's changed here, right? Like, these companies have really started to, all of them started out like this, right? And none of these companies have started to close the gap between their traditional model of developing software, where they're building, deploying, and running their application in this rather sequential form, and the style of application that they were developing is what we're starting to call monolithic applications. And the deployment itself was very destination specific, meaning it was to a particular VM that everybody kept track of, and then essentially cared, fed, and nurtured by deploying very sparingly at very specific designated times, because a number of different roadmaps had to come together for all the different features at the same time, right? So many different tools and a bunch of ad hoc automation that was built, bespoke for every single application. Now, contrast that now with how some of these companies are largely deploying microservices, or at least with some degree of cloud native conversion for their applications, right? And what that does is having these individual microservices decoupled and having their life cycles decoupled allows them to have shorter cycles, do automated testing like you've heard from the speaker before me, and essentially be test driven and be iterative with how they do their deployments. And the other interesting thing is that they're no longer thinking about being destination specific. They're deploying their application on what I like to say disposable infrastructure, which doesn't mean you don't need infrastructure, but it just means you no longer have to keep track of it, right? And that platform essentially figures out where your workload goes. And what that does is it lets you be ready for production at any time, right? And you're thinking about your deployments in terms of managing these application services and not necessarily thinking in terms of, I'm going to deploy to this particular server, right? So it frees you up from that. This comprehensive shift in the model for application delivery is what the industry is calling cloud native, right? Now, we're all here to talk about DevOps. This is the DevOps track. Now, DevOps is definitely a part of this. If you think about it, cloud native is really an advanced combination of DevOps, microservices, continuous delivery, all practiced with the goal of shipping more resilient software faster, right? And what does all this take? Did you ever try to do microservices without CI/CD? Ever try to adopt CI/CD without practicing some kind of DevOps? Ever try to do ops for microservices without an automated platform? Turns out they're all connected, right? So this is where Pivotal is focusing, right? And this is where we come in. Our vision is really to provide a full solution for the enterprise to efficiently handle the operational impact of these cloud native delivery models and be the DevOps enabler, if you will, and push more and more of that operational decision making and some of those manual tasks into the platform itself. And the cultural contracts, the shared tools, and the shared vocabulary of all of the teams, the contracts between the teams, push all of that into the platform. Now, when a developer wants to push an app, right, we all want to push code. we enable self-provisioning and cut down that wait time, right? And the platform supports multiple languages and frameworks. It automatically detects essentially what kind of an application was pushed and takes care of all the rest of the things that are required in order to get the runtime resources involved in giving you that deployment artifact. And once you've got your application, you want to make sure it stays up, right? So lest you have some issues there, we have 4 layers of protection built to keep your application available. Now, if an application instance fails, the platform essentially restarts it in a new container. If there's a problem detected inside the virtual machine, Cradle Cloud Foundry kills that VM and spins up a new identical type of VM, and this could essentially be the VM that's also running some of your app services or maybe your Jenkins or something like that. But it will spin up that type of VM for you. Now, if a process inside of the platform itself fails, the platform will restart it. That is, if a failed cluster component essentially stops working, that's restarted, making this a self-healing system, right? And this is all, again, automated, so it's not, you can come back and, analyze what went wrong with the system, just not at 2 a.m., right? In addition to that, the runtime is actually one of the most mature Linux container scheduling environments in the world today, right? When you have new work as it arrives, the platform distributes that work and uses a pretty sophisticated process to do that. So an algorithm essentially rebalances the application processes over the virtual machines, and an auction determines which processes should be allocated to which VMs while optimizing for application availability and for resilience. Now, the platform also monitors these applications, and if any of them crash, they get restarted, and then they get rebalanced across the available capacity. And as mentioned before, the platform attempts to revive those VMs, and none of that actually requires the human intervention. And finally, you can also set this platform up to distribute instances across application availability zones. So if an AZ is lost, the app instances just keep on running, right? It will also dynamically balance the load to optimize for that. And finally, the platform is connected to a huge ecosystem of services so that all of the things that your application needs, including what you need for microservices and CI/CD, like Cloud-Beast Jenkins, all of those are actually also available as part of the platform. And finally, the platform is connected to a huge ecosystem so that all of the services are available for your app. And I don't want to take up the entire time here, but if you want to discuss more about how you can get automation, visibility, governance, resiliency, please stop by our booth, and I'll be happy to talk some more about it. This is a lightning talk, and I do want to stay within my time. And I'm also on Twitter if you need to have a conversation, always available. Thank you.